Neptune has been guarding a ferocious secret for over 3 decades, and when James Webb finally tore away the veil, the images and data that came back don't make sense for a supposedly cold, distant ice giant. Something is profoundly wrong with how this world operates, as if the laws governing planetary behavior are being quietly rewritten right in our cosmic backyard. Stay right here with me, because once you see what just uncovered, you'll never look at the outer solar system the same way again. Since NASA's Voyager 2 raced past Neptune in 1989, we've relied on grainy snapshots and models of a serene blue ice giant, methane-rich atmosphere giving it that striking color, supersonic winds, a faint ring system, and extreme distance from the sun making it seem frozen in time. Then, starting with breakthrough observations in 2022 and powerful follow-ups through 2025, the James Webb Space Telescope trained its near-infrared instruments on the planet, delivering the sharpest views of its rings and atmospheric details in more than 30 years. What we thought was a relatively quiet world suddenly came alive in infrared light. But then something strange happened as the data poured in. Far from the stable, predictable planet textbooks described, Neptune revealed intense mid-latitude auroras, clumpy dynamic rings, unexpected cloud formations, and an internal heat engine pumping out more energy than it receives from the sun. The calm blue marble of the outer solar system started looking like a turbulent, active beast hiding its true nature. What if everything we assumed about ice giants was incomplete, and Neptune is actively demonstrating forces that could reshape how we understand planet formation, evolution, and even the prevalence of habitable conditions across the galaxy? Is it possible that this distant world holds clues to why our own Earth remains stable enough for life, while so many others turned chaotic? And what does that mean for our place in the cosmos? Let's break it down chunk by chunk, so the full picture emerges without losing the wonder. Begin with those legendary rings. Voyager gave us the first close look, spotting several narrow bands and hints of dust. But for decades they faded from view, too faint for most telescopes. US changed that dramatically. Its infrared sensitivity cut through the distance, revealing crisp, bright rings alongside fainter, dusty structures. Some rings appear clumpy and variable, maintained by gravitational dances with small moons acting as shepherds. Dust bands suggest ongoing replenishment from collisions or moon activity, evidence of a system that's far more dynamic than a static relic from formation. Next layer, the atmosphere itself. Methane gas absorbs red wavelengths, painting Neptune deep blue, but JWST appears at different depths, exposing high-altitude methane ice clouds and bright storm systems. Winds exceed 1,000 miles per hour in places, the fastest in the solar system. Even more puzzling, the planet emits roughly 2.6 times more energy than it absorbs from sunlight, hinting at powerful internal processes driving weather and circulation on a massive scale. Bright patches and vortices appear and shift, showing a meteorology far more vigorous than expected this far from the sun. Then come the auroras, captured vividly in 2025 observations. Unlike Earth's polar lights, US detected bright emissions at mid-latitudes, caused by energetic particles from the sun or magnetosphere interacting with the upper atmosphere. This suggests Neptune's magnetic field is complex, possibly tilted or offset, creating unusual interaction zones. The glows shimmer and pulse in infrared, painting a picture of constant particle bombardment and atmospheric response. But that's not even the strange part. As researchers dug deeper, scientific disagreement exploded. Why does Neptune have this excess heat? Theories range from leftover gravitational energy from formation to helium raining out and releasing energy, or even diamond formation deep in the interior under crushing pressure. The ring's clumpiness challenges models of long-term stability. Why haven't they dispersed or settled after billions of years? Atmospheric composition shows surprises that don't perfectly match predictions, and interactions with moons like Triton, which orbits backward, add gravitational chaos that may stir the system. Some astronomers argue this forces a rethink of ice giant formation, possibly involving dramatic migrations across the early solar system, or giant impacts that left Neptune with its odd rotation and magnetic quirks. Others push back, saying our models just need refinement. The tension is real and ongoing, with just data refusing to fit neatly. Layer upon layer, the mystery expands. Consider the moons. Gestado also sharpened views of Triton and others, revealing surface compositions and orbital resonances that hint at captured objects or violent past events. The entire Neptune system feels like a laboratory of extremes, cold yet internally heated, distant yet active, ringed yet dusty and evolving. Each new filter on JWST reveals fresh details, faint bands, cloud evolution, and magnetic influences that astronomers are still modeling. Zoom out now to the truly big stakes for Earth, the universe, and us. Ice giants like Neptune represent a huge fraction of the exoplanets we've discovered around other stars. What JWST sees here helps decode conditions on those distant worlds. Do they host similar hidden energies, dynamic rings, or auroral displays? For our solar system, Neptune likely played a key role in the late heavy bombardment, scattering asteroids and shaping the orbits that allowed Earth stable conditions for life. A slightly different Neptune might have meant no moon-forming impact or altered asteroid delivery of water. Emotionally and scientifically, it humbles us. The universe is full of worlds with hidden fury, making our pale blue dot feel even more special and precarious. It drives home the need for continued exploration. Missions to ice giants could unlock fusion power clues from helium processes or teach us about planetary migration that affects habitability everywhere. On a human level, it sparks that mix of awe and unease. We thought we understood our neighbors, but space keeps proving how much wilder reality is. Tying it all together, that initial shock of Neptune defying expectations after 30 years of relative quiet now feels like the tip of something much larger. JWST has shown us a planet that refuses to be simple, leaving core questions unanswered. Exactly what powers its internal furnace over billions of years? How do its rings persist in such dynamic form? And what broader lessons does this hold for the thousands of similar worlds out there? The open tension invites us to wonder what other surprises lurk in the darkness between stars. Staring at Neptune's revealed turbulence, do you find yourself more excited about the universe's untamed nature, or a little more protective of the fragile stability we enjoy on Earth? And what does that say about how we should explore going forward? Share your genuine reaction below. These conversations matter. If this deep dive into what James Webb uncovered about Neptune fired up your sense of cosmic curiosity and wonder, take a second to follow for more. Share it with friends who stare at the night sky, and help spread these stories that remind us how extraordinary our universe truly is. Your clicks and comments keep the exploration alive for everyone.